Okay, we're going to stick with our geometry unit, and now we're going to talk about some shapes that are a little bit different. So you'll notice that what I've got up here is the I can statement. So section 11.6, I can compute the circumference and area of circles. And then I've got just a quick warm-up review of going over the formulas that we've learned so far for parallelogram. It's base times height, and I happen to draw a little rectangle right there. So if you need to pause this and get these written down, that's fine. Go ahead and pause it. But I'm just going to kind of continue talking about these. So I've drawn a rectangle right here, but a rectangle is just a special type of parallelogram. We can also have it kind of tilted on its side a little bit, something like that. And again, what's important is that the height is the distance between those two parallel sides. So it's got to be that perpendicular distance. So that's why I've got the right angle right there. And then we've got a triangle. The formula for the area of a triangle is 1/2 of the base times height. We talked about the reasoning for that. And then trapezoid, the area is 1/2 of, and this is parentheses, so it's the quantity of B1 plus B2. These are the two parallel sides on a trapezoid. So B1 I've got written here and B2 here. And again, these little subscripts, these little numbers are just a way of keeping straight which one's base 1 and the other one is base 2. So we recognize that they're different. So we've got 1/2 the quantity B1 plus B2 times H. All right, and now some other warm-up questions here. So for question B, it's what is the distance across a circle through the center called? So if we've got the center right here and we draw the distance across, it goes right through here, not over here, not over there, but right through the center. As long as it goes through the center, it has a name. So hopefully you remember what that name is. It's called the diameter. So diameter. All right, and we're going to use a D to represent that. And then the distance from the center to the edge of the circle, that is called the radius. Radius. So we're going to use an R to represent that. And then it says, what is the number pi? And this is the Greek symbol for pi. And we spell it pi, not pie. So what is the number pi and where does it come from? In other words, what's the definition of pi? Well, you've probably heard of pi before, but let's talk about where it comes from. Pi is approximately, and I'll use that symbol again, so it's kind of like a squiggly little line with two legs on it. Okay, it is approximately 3.14159, and this actually goes on forever and it never repeats. So 3.14 is a pretty good decimal approximation. So if we go to the hundredths place, and if we were to talk about a fraction that you can use to represent it, 22/7 is a pretty good fraction. In fact, I'm going to pull up the calculator really quickly and just show you how close this is. So 3.14159, that's out to 5 decimal places. So I'm going to clear this off and I'm going to do 22 divided by 7. 3.1428. So it's pretty darn close. We're within a thousandth or so. So that's pretty awesome. All right, so 3.14, we can use that as an approximation. 22/7 we can use that as an approximation. Your calculator actually has a pi button on it, and it's got it accurate out as much as you could possibly need. Now, where it comes from, that's a great question. So I'm going to draw a circle again, and I'm going to draw a diameter. Okay. And so here's what we've got. We've got this circle, and we've got an outside distance, the perimeter, if you want to think of it that way. That's called the circumference, and then we've got the diameter. So the diameter is right here, and then all the way out around the outside is the circumference. So pi is actually a ratio. Pi is the ratio of the circumference divided by the diameter. So that's what pi is. Now, it doesn't matter how big or how small the circle is. It can be the size of the earth. It can be the size of a pop can. Whatever it happens to be. If it's a circle, if you took a string and measured how far it is around the outside and then measured straight across through the center, if you took that distance around the outside that we call the circumference and the distance through the center that we call the diameter, and you do a little division problem, it's going to work out to be 3.14159, blah, blah, blah. If you're in my classroom, I actually have a poster of it. It's probably accurate out to maybe a couple hundred decimal places or something like that. You can also look it up on the internet. They have this out to probably a few billion places, so it's pretty crazy. All right, so circumference, and I'm actually going to write that word, circumference. Okay, that's a fancy name for the perimeter of a circle. All right. Now, the interesting thing about this is we can kind of take this and we can manipulate it a little bit. So we're going to come back and we're going to do that in a few minutes. But what I want you to do is do a couple of these follow here. And we're going to be using a few of these today, and we're going to be using the idea of squaring a lot. So if we do 2 squared, it doesn't mean 2 times 2. We're not multiplying the base and the exponent. It means use the base twice. So we do 2 times 2, we end up with 4. And again, over here, we want to use the base twice. So it's not 3 times 2, it's 3 times 3. So you've got to know why this is 2 times 2, because we're using the base twice. Use the base twice, 3 times 3, so we end up with 9. Use the base twice. The answer on this one is not 8. We do 4 times 4, so that's going to be 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. Those are some very common, we call these perfect squares, perfect square numbers. Okay, so perfect squares, and those are going to come in handy today. Now, there are 2 formulas that we're going to use when we're talking about circles, and people get these confused. And I'm going to show you a way that you can keep these straight. So here are the formulas. The circumference formula is 2 pi r, and the area formula is pi r squared. So circumference is 2 pi r, and the area formula is pi r squared. So the circumference formula comes from the definition of pi. So I'm actually going to show you where this comes from. So I want to show you something up here that you may have seen before. So if this is how pi is defined, take the circumference and divide it by the diameter. What we could do here is I'm going to change colors. I could actually solve this for the variable c. I'm going to multiply this side by d, and I'm going to multiply that side by d. Those are going to cancel, so I end up with this. The circumference equals pi times diameter. Now you'll notice I didn't say circumference equals pi times diameter. I said circumference equals 2 pi r. Now if we come back over here and take a look, this is the diameter. But this line goes from the center to the outside, and this one goes from the center to the outside. So this is a radius, and this is a radius. So what that means is a diameter is exactly 2 times a radius. So what we do is we use that information, we come over here and we say, okay, that means the circumference is pi times 2 times r. And we normally write the coefficient out front, so that's why we write the 2, then the pi, and then the r, and that's where we come up with that formula. Okay, so you've got to get this memorized, and you've got to get this one memorized, and more importantly, you've got to make sure you keep these straight. So I want you to take a look. This has a 2 and a pi and an r, and this has a pi and an r and a square. So they both have a 2, they both have a pi, and they both have an r. So how do you keep these straight? Well, one way that you can keep straight where the 2 goes, it's a question of whether it's a coefficient in front or an exponent on the r. The way you can keep this straight is you can remember what area is. Area is always measured in square units. So if it's measured in square units, we had to do some squaring in there somewhere. So if you can't remember if it's 2 pi r or pi r squared, the one with a square in it is going to be the area. Okay, so make sure you get those memorized and keep those straight, and let's take a look at a couple of examples. So we're going to look at a justification for the area formula in just a minute, but for right now let's just go ahead and use the formulas and figure these out here. Okay, so it says find the circumference and then round to the nearest hundredth and use the correct units. You're going to use your calculator for this. So what we have here is we have the radius. Notice that we've got this dot in the center and then the line that goes to the outside. So we know that that's the radius. So it says find the circumference. Now, like everything else when you're learning these formulas, if you'd write them down a couple times, that's really going to be helpful. So I'm going to write down 2 pi r. So on this problem we've got 2 times pi, and then the radius is 27 centimeters. So I'm going to go ahead and pull up the calculator. You can use your calculator on this. The pi button on my calculator is right there. So here's what I'm going to do. I'm going to clear this off, and I'm going to type in 2 second pi. That brings it up right there, and then I'm going to multiply that by 27. Now if you want to put multiplication in between each one of those, remember the calculator knows what implied multiplication is, so it's all set to go. So here we go, 169.646. If we're going to the nearest hundredth, that's going to be this 4 right here. So we look at one past that. If that's 5 or more, we bump it up to a 5. If it's 4 or less, then we leave it the 4. So the choice here is either 0.64 or 0.65. That's big enough we're going to bump it up to 0.65. So 169.65. 169.65. So that's the answer, but remember we need units on this. This is a circumference, it's a distance around the outside, so that's just a linear measurement as we call it. It's just going to be centimeters. Now if you take a look at this next one, this one's kind of interesting. You'll notice the diagram looks a little bit different. We've clearly got a different measurement right here. But this line goes from one edge all the way through the center and then all the way to the other side. So this is a diameter. So if you know the diameter is 78 feet, how would you figure out what the radius is? Well, remember back up here what we said about the radius? The radius is twice as big as the diameter. So we don't want the whole distance across there. We only want half of it. So we're going to divide that by 2. So we're going to do 78 divided by 2. 78 divided by 2. If you need a calculator for that, that's no problem. I think you're going to end up with 39. Should we just double check? 78 divided by 2. We end up with 39. So this is going to be 39 feet. So again, the formula is 2 pi r. So this is going to be 2 times pi times 39. So again, I'm going to pull up the calculator. I'm going to type in a 2. I need to hit the second button to grab the pi. That may or may not be the case on your calculator. If you're using a TI-30, it has a regular old pi button on it. In fact, it's right about there that there's a pi. And then I'm going to put the 39 in here. Again, it understands the implied multiplication. We're going to multiply them together. We get 245.044. So the question is it 0.04 or can we bump it up to 0.05? Well, since that's a 4, we're going to leave it 0.04. So this is going to be 245.04. And then remember, this is just the distance around the outside, so it's going to be a linear unit of measurement. It's just going to be in feet. Okay. It says find the area of the two circles above. So I'm going to write down the formula. Area equals pi and then r squared. So on this one it's going to be pi and the radius is 27. Now I'm going to put that in parentheses and square it. So on the calculator, here's what we're going to do. We're going to do pi. So pull up the pi button or hit that. And then we're going to do 27 squared. So there's the squaring button on this particular calculator. Yours may be just a little bit different. So we're going to square that and we end up with 2290.221 blah blah blah. So it's either going to be 0.22 or 0.23, and to figure out whether we change it, we look past here. This is just a 1, so we're going to leave it 0.22. So it's 2290.22. 2290.22. Now I'm going to leave some space to put the units on here. Remember, this is measured in square units. This was centimeters, so we would have squared those centimeters, so this is going to be centimeters squared, and there's our answer. Okay, next one. Again, please write these down enough that you get these straight. We're talking area, so it's going to need to be pi, and then the r has the 2 on it, so it's pi r squared. So this is going to be pi. We figured that this one was 39. And we're going to square that, so I'm going to bring up the calculator and throw that in. Here's the cool thing. If you want to up arrow on yours, you can actually just edit this. I'm just going to change that to a 39. If you want to put it in from scratch, that's totally okay. We get 4778.36. Again, the question is this going to stay 36 or is it going to go to 0.37? That's a 2, so it's not enough to bump this up. So we're going to do 4778.36, and then again the units here are feet, so this is going to be square feet or feet squared. Okay, now if you flip the page over, I told you that we'd go through some justifications and things like that. I'm going to draw a picture of a fairly typical justification. You can kind of just watch. If you want to draw this, that would be fine. I'm going to give you some things and some resources that you can look at that might make this a little bit better. So here's what we're going to do. Imagine that this is kind of like a circular orange. So a nice circular shape, and then we draw the sections of the orange in there, or pizza slices or something like that. So we're going to do this. We're going to draw some lines out here. We're going to draw a whole bunch of them. All right, so we're just drawing the sections in there, making it look nice. So it looks like this. And then what we're going to do is we're going to take a knife and we're going to make a little slice. Let's say we make a slice about right here. Okay, so we slice all the way to the inside, and then maybe you've done this before with orange slices. If you take it and kind of tear the orange peel a little bit, and then kind of spread it out, here's what happens. You get shapes that look like this. Now I'm going to draw, I think I drew 12 slices. So the slices are going to look like this. Let me see if I've got enough right here. Okay, and I'm kind of making these nice and straight. So I've got 3 and 6 and 9 and 12. Okay, and then here's the orange rind right here. Okay, so it looks like that. Looks like a bunch of teeth that are sticking up here. Now, what I'd like to know is how far is it from the top of this triangle down to here? How far is that? Well, it would be any one of these triangles right here. So it's the distance from the orange peel out to the center. So that's going to be the radius. So that's going to be r. Okay, then I've got another question. How far is it from here all the way over to there? So in other words, when we cut it along here and kind of spread this out like this, how far was it from here to here? Well, that has a name. That's the circumference. And the circumference is 2 pi r. That's the formula for circumference. Okay, so the distance from here to here is 2 pi r, and the distance from top to bottom is just r. Now, what we're going to do is we're going to do something kind of clever. We're going to take this, and I'm going to cut this in half. So we've got 3 here and 6 here, okay? And then 3 here and 3 here. So I'm going to cut it right there, okay? Now, what I'm going to do is I'm going to take this, and I'm going to take this part right here, and I'm going to fit it in right there. I'm going to fit the teeth of that together. So here's what it's going to look like. So we're going to have 1, 2, 3, 4, 5, 6. Oops, let me just do the 6 there. Okay, so we're going to have 6 there, and then we're going to take the 6 from over here, and we're going to bring it up here, and we're going to put them together. So this is going to be looking like that. 1, 2, 3, 4, 5, 6. Okay, so in fact, I'm going to color code this. I'm going to do these in yellow. Okay, so these are the ones that are on the top. And I'm going to do these in kind of this bluish, yeah, I guess that's a green color that I've grabbed there. Okay, so that's what I've got. Okay, and if this were an orange, it wouldn't fit together perfectly, but let's say these were nice triangles that fit together really well. Then this would just fit together, and I want you to look at it, and I want you to think about what shape this would be. So what shape would this whole thing be here? Well, it would be a parallelogram. So I'm going to kind of draw the outside, kind of emphasize that. That would be a parallelogram. Now, how far is it from the top to the bottom? Well, I'm going to erase one of these. It's going to be, whoops, it's going to be r units tall. It's going to be the radius. And how far is it from here to here? Well, it's 2 pi r on the whole thing, but remember, we cut it in half, so how far is it from this to that? How long is the base, in other words, of this parallelogram? Well, if we cut this in half, we basically get rid of the 2, so this is going to be pi r. So what we've got is a parallelogram that looks like this. The base is pi r, and the height is r. So what would the formula for the area be? Well, it's going to be the base, which is pi r, times the height, which is r. So if you multiply those together, then you end up with area equals pi, and the easiest way to write r times r is just r squared. So I'm going to come back up here and I'm going to write that. So the formula is pi r squared. Now, I've drawn some pictures here. They're not the greatest and stuff like that. If you want to go to these, I've made these tiny URLs. If you go to these websites, it'll link you to some pretty cool stuff on the internet. So I want to show you what those are. So again, you need to pull these up yourself so you can hear the sound and stuff like that. But it will go through, I've got 3 of them that go through there and talk about the area of a circle and where pi comes from. And if you watch some of those, you should be in pretty darn good shape. Okay, so let me get rid of that, and I'm going to come over here. This is the last one. Okay, so this is that one right here. So I did it tinyurl.com area just for area justification. So if we come over here, this actually has an area kind of justification or an argument or a proof for each one of these. So for rectangles, triangles, parallelogram, a couple for triangles, a couple for trapezoids, and then a couple for circles also. So if you go to those websites, you can kind of see a good justification for each one of those. So I'm going to go ahead and close this, and I'm going to come back here. Go ahead and overwrite that. So I would really recommend going to those websites and taking a look at those. They're very short. Some of them are only about a minute long, but they're very good in showing you how those work. So I'm going to come back here, and then we're going to use these formulas to do a couple other examples, and then we can turn you loose on the assignment. So example 3, it says compute the following. So compute the area if the radius is 12.6 inches. So we're going to be using an area formula, so let's write down what that is, pi r squared. And it says figure out the area if the radius is 12.6 inches. Well, this is the same as the other side, they just didn't give us a picture. So it's going to be pi times 12.6, and we're going to square that, so we'll grab a calculator. We're going to do I'll clear this off, we're going to do pi, however you need to bring that up on your calculator, 12.6. I'm going to square that, and we end up with 498.759. So the question here is, should we write 7.5 or should we do 7.6? This is a 9, so that's enough to bump that up to a 6. So 498.76. 498.76, and since this is in inches, this is going to be inches squared. Okay? All right, let's take a look at this one right here. Let's see, circumference if the radius is 4.1 miles. So we know we're going to be finding the circumference, so we've got to have the formula, so that's going to be 2 pi r. And it says the radius is 4.1 miles. So the circumference is going to be 2 times pi times whatever the radius is. The radius is 4.1, so we're going to multiply those together. So on the calculator, we're going to do 2 and pi, and then times 4.1. Again, it understands the implied multiplication, so we get 25.76. It's either going to be 7.6 or 7.7. That's only a 1, so it's going to stay 7.6. So 25.76, and then again we've got to have the units. Remember, this is just a circumference. This is just the distance around the outside, so we're going to go ahead and put miles right there. Okay, so we've got that. Let's come down here and take a look at the last couple. The next problems are kind of the opposite of what we've been doing. So as we go through here, it says find the radius of the circle whose area or circumference is given below. So they're going to give us the answer, and we need to back up and we need to find out what the radius is. So notice it talks about circumference, so let's remember what that formula is. Formula for circumference is 2 pi r. What it says is the circumference is 6 pi, so that is going to go right here. So 6 pi is equal to 2 times pi times r. Now this is a little bit interesting because we've got these symbols floating around and stuff like that, but let's say we were solving this problem. Let's say it was 6 equals 2 times x. Everybody here would know what to do to solve that. We're going to divide by 2. Well, we don't want to just get rid of the 2, we want to get rid of the pi also. So we're going to divide both sides by 2 and by pi. The 2's cancel, the pi's cancel. Now look at what happens over here. This is kind of cool. The pi cancels with the pi. Pi divided by pi would be 1, and then 6 over 2, 6 divided by 2 is 3. So there's our answer. The radius is 3, and remember, if the circumference was in inches, the radius is going to be in inches. Okay, so there's our answer on that one. We've got an area here, so we're definitely going to use the area formula of pi r squared. Again, write that enough that you've got it memorized. And then it says the area is 64 pi. So we're going to do, let's see, 64 pi equals pi and then r squared. This can be a tricky one if you haven't seen these before. And so we've got 64 pi equals pi r squared. Now this is going to take a little bit of thought, but see if you can follow this. This is the variable right here. We want to figure out what the radius is. I mean, it even says that in the instructions, find the radius of the circle. So you'll notice we've got a pi on both sides, so we can do something similar to what we did over here. We can divide both sides by pi. So I'm going to cancel those off, and we get this. 64 equals r squared, or 64 equals the radius squared. So stop and think for just a second. We're going to take whatever number the radius is, and we're going to square it, and we're going to get 64. Now remember, if we come back up here, and we look at that warm-up question where we're talking about perfect squares, so we've got 2 squared is 4, 3 squared is 9, and so forth. Is there, well, let's see, the next one would be 8 squared, and 8 squared would be 64. So at this point, this is kind of a little bit of guess and check here. It's definitely bigger than 7. 7 squared is 49. 9 squared is 81, so it's got to be somewhere in between there, and 8 squared is 64, so that's what it is. So the radius on this one is 8, and since this was in square feet, the radius would be in just plain old feet, okay? So if we take a look at this right here, that's it. Now I do want to have one more little thought question here. It says, what is the diameter in the circle of example 4a above? So here's 4a. We found the radius. What's the diameter? Well, remember, the diameter is twice as big as the radius. The radius is halfway across, the diameter is all the way across, so we're going to have 2 radiuses. So if we just doubled that, so we're going to take that 3 inches, we're going to times it by 2, and we end up with 6 inches. Okay, some really good thoughts here. Again, I'd really encourage you to go through and look at those justifications. They're pretty quick little videos and animations. I think you'll really like those and they'll help. But either way, you've got to have those formulas memorized. Those are going to come up this year and next year, probably in every math class you take until now and from now until you're done taking math. So there you go, and good luck on the assignment.